Now we're going to work with amines and amides, or amides, however you want to pronounce it. These, again, are very linked, and they're linked with, amines are, there we go, ends with at least 3 things bound to it. And amides are nitrogens next to, with at least 2 more linkages on it, attached right next to a carbonyl. So this would be an example of an amine, and over here we've got our example of an amide, or amide, however you want to pronounce it. So amines are really important for amino acids, and after they condense with a carboxylic acid, like so, I'm going to draw it out like this. We'll just make it really simple. Okay, there we go. So once they condense, and again in condensation we lose water, and those parts can only come from functional groups. So we'd lose it right there. It doesn't matter this H or that H. The water gets knocked off. So then this bond right here, which is missing, will then become attached to that bond right there that is missing. And we end up with C double bond O with a purple bond right here to our amine, and this is what makes an amide or an amide right there, that purple bond. Carbonyl right next to a nitrogen. It's formed from an amine. So these with their names, it's really, really easy to kind of like get them mixed up. So don't beat yourself up over that. But there's still a very, very important distinction. Okay. So now let's go ahead and practice some naming with these. So amines, again, because these could be anywhere, they could be in the middle, they could be on the end, it doesn't really matter. It's really important to include the number of the carbon that they're attached to. CH3, CH2, 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 and H2. So in this example, it's a primary amine because there's only 1 carbon attached to it. So when we draw this as the skeletal structure, there's 1, 2, 3, 4 carbons, then an amine on the very end. 1, 2, 3, 4, and then an amine on the very end. And that should be an NH2. I owe myself a nickel. NH2. Nitrogen has 3 bonds, carbon has 4 bonds. Okay, so this could have been in the middle, it could have been over here, we don't know, so we need to make sure that the numbering is correct. We start with you can always start numbering on the carbon closest to the functional group, 1, 2, 3, 4, because if you try it from the other side, 1, 2, 3, 4, the closest one's always going to win. So this is going to be 1, and then we're going to say what the functional group is, amino, and then we're going to name the longest chain, has 4 carbons, so that's bute. There's no double bonds here, so that's an ane because it's an alkane. So we add the amino as a prefix, which is kind of different than some of the other functional groups. 1-aminobutane. Okay. Got a really, really simple example of an amide for you. CH3, CONH2. So this is what tells you it's an amide. This, with no additional CO groups, that's what tells you it's an amine. Amide, the D is like for double bond. It's like C double bond O, which is right here. So when we draw this out, it's going to be CH3, C double bond O, NH2, right? Okay. So in full skeletal, it would look like this. Okay. And the way that we're going to name this, again, this could be anywhere. So this is on the carbon closest to it. 1, 2. This is going to be 1, because that's from that carbon. And then you name the chain. So there's 2 carbons, so that's eth. So that's going to become ethyl, because it's not the last thing that you're saying. And then you add the word amide. So number where it is, how many carbons in the longest chain, plus the word amide.